Next, I want to talk about combining like terms. The distributive property is something we can use to help us simplify expressions and get them ready so that we can deal with them in equations. Combining like terms is another one of those steps. A lot of times you will get different terms that are separated that when you put them together, it makes the problem a lot easier to do. You can simplify an expression by combining real numbers and terms which have variables that are exactly the same. Now, what does that mean? If you take a look at my first example here, I've written 3x plus 5x. The variables are exactly the same. I have x and x. I'm allowed to combine those. So when I add 3x and 5x, I end up getting 8x. Now occasionally I'll get somebody that wants to write 8x to the second. They think, well, I have to add the 1 and the 1. That's when you're multiplying. When you're adding, you're just adding up the coefficients, the numbers that are in front. Okay, how do I know that 3x plus 5x is 8x? Well, a simple way just to kind of demonstrate it is, what if I tell you x equals 3? Now x can be any number you want. I just randomly picked 3. But we put in a 3 for the x because that's what it equals. Well, 3 times 3 plus 5 times 3, that would give me 9 plus 15. 9 plus 15 is 24. If I put the 3 in here, I would get 8 times 3, that is 24. They give you the same answer. It's just a lot easier to calculate with this one. Something else some of you may notice is that there is an x in both of those, isn't there? We just learned about distributive property. If x got multiplied times both of them, x could be in the front, and this could have been 3 plus 5. All right, because x times 3 is 3x, and x times 5 is 5x. Well, order of operations, you add it. 3 plus 5 is 8. So there's your 8x. A couple different ways to show that. In essence, though, if the variables are exactly the same, you're allowed to add them. If the numbers, in whole numbers or real numbers, you're also allowed to add those. All right, so I've got 4 examples up here to run through really quick. I've got negative 7y plus 4y. Again, the variables are exactly the same. Negative 7 plus 4, I hope you realize, is negative 3. So the answer there is negative 3y. Now on this one, I've got 9 plus 2x minus 7. The 2x is sitting here, and there's nothing else with an x. If there's none, you just write it again. So that would be 2x. If there's nothing to combine it with, there's nothing to combine it with. And what is 9 and negative 7 when you combine 9 and negative 7? I hope you realize that's 2. Since it's positive 2, I'm going to write a plus. If when you combine them it's negative, you write a minus. The third example has a 6n and a 4n, but this is buried inside some parentheses. Before you combine things, you've got to get rid of the parentheses. You're going to use the handy-dandy distributive property, because the distributive property gets rid of parentheses. It makes it so that we can combine like terms. So 3 times 1. Now I want to point out, this is plus 3, so I'm treating this 3 like it's positive. If this had been minus 3, I would have treated this 3 like it's negative. 3 times 1 is 3. 3 times negative 4n is negative 12n, so I'm going to write minus 12n. And the 6n, I'm just going to do a rewrite for. This 3 is positive. Since it's positive, I write a plus. Now I can combine the n's. I have 6n and negative 12n. When I combine 6 and negative 12, I get negative 6n, and the plus 3, since there's nothing there to combine it with. My last example has x's in it. And so we look at it and say, well, we can put this whole thing together. Slow down. X to the second, x to the third, x to the second, x to the third. When I said exactly, I meant exactly. X to the second is different from x to the third. We can take the x to the seconds and combine them. So 2x to the second plus 5x to the second is 7x to the second. 3x to the third and negative x to the third. I don't have a number there. Yes, you do. Remember, that's one of the spots where there's an understood 1. If there's not a number in front of the variable, treat it like there's a 1 there. 3x to the third minus 1x to the third would be negative 2x to the third. Now, some of you may be looking at this and saying, we got a problem. The 2 comes before the 3. You're thinking in descending order. If the problem tells you the answer has to be in descending order, you need the largest variable first. So then I'd have to rewrite this as negative 2x to the third plus 7x to the second. Now, if it doesn't say anything about descending order, you can actually leave it like that. So it is correct as long as it doesn't tell you to put it in descending order. Notice when I switched them, the 7 is positive, it became plus 7x squared. This 2 is negative, so I had to write negative 2x to the third. Good luck.